Good morning, 8th graders. I want to go over the two rules that we learned not yesterday, but the day before. We learned about when we multiply, remember this is multiplication, and when we divide. Here, remember, in order to use the tricks we learned, we need one thing to be true. And that is, we need the base to be true. And you might be thinking to yourself, I'm not sure what the base is. And that is what we are reviewing. Here we have a base of 9, and I'm going to type that in. This is the base. If the bases are not the same, then we cannot use our tricks. Here, 9 squared times 9 to the 5th, that means that you have 7 9s altogether. When we multiply, that's how we got that 7 by adding the exponents. I also want to make a note that this 2 and this 5, they do not need to be the same, and we call those exponents. I hope that some of you already knew this, but just in case you didn't, these are the bases and these are the exponents. So for 9 to the 7th power, think to yourself for a minute, what number is my base? Our base is 9 here, and our exponent would be 7 then. Okay, I want to make a note that down here, if we added the exponent 3 plus 13, we can't really do that. And I want you to think to yourself, why can't I add my exponents on this one? The reason why we can't add our exponents is because our bases are not the same. This means that I have 5 times 5 times 5, just like from the notes yesterday, and this times 8, oh geez, these a lot of 8s. 1, 2, 3, 4, 5, 6, 7. I think that's 13, but I'm not for sure, but times 13 eighths. So can I conclude that I have 16 5s in all, or 16 eighths in all? No, we cannot. So that's why we cannot use a trick if the bases are different. And just a reminder up here, this is the same as saying 9 times 9, 9 squared, times 9 times 9 times 9 times 9, 5 9s. Okay, and that's why we conclude that altogether we have 7 9s, 1, 2, 3, 4, 5, 6, 7, and that is how we got 9 to the 7th. But down here we cannot conclude that we have 16, 3 plus 13, 16 5s, or 16 8s, and that is why the bases need to be the same. So let's take a look over here at dividing. The same rule applies. We need the same base in order to divide. So I want you to take a look at these. This is 11 to the 14th power divided by 11 to the 8th power. This is 10 to the 9th power divided by 16 to the 6th power. Take a second to think, which one could I solve and what would it equal? Okay, so let's start first. The one that we can solve is this one because the bases are the same. Here I have the base of 11 in the numerator and denominator. Remember, the trick with dividing was that we can subtract 14 minus 8, and that is how we would get 11 to the 6th power for our answer. Okay, and if it helps you, I want to remind you, this is a lot of 11s, but that is 11 times 11 times 11, 14 times. I'm not going to continue, but that divided by 11 to the 8th power. Okay, so I just wanted to remind you, I'm going to erase this, but if I had 14 11s in the numerator times 11 times 11, we would keep going on. I just wanted to remind you from the video yesterday. Okay, so here, again, we cannot solve this because our bases are not the same. I can't say that I would have um, 6 11s left over after I cross these out because I only have 10 and 16, okay? We can solve this, but not with our tricks, and we aren't going to work on solving those right now. I do want to remind you of one more thing. Thank you for watching this, but if I had, say, 10, I can draw this. Say this 11/14, 11 to the 14th power was written like this. That is okay. We can change that to look like this. 11 to the 14th power goes up top, and 11 to the 8th power goes in the denominator. Okay? So I'm going to circle that because that is important to know. Sometimes you might see the division set up like this, and that is okay. All right, thank you for watching. Have a